All right, hopefully you watched the 7-1 podcast. You know what? If you're watching one of these podcasts and you're having a problem and you don't understand something, email me. I check my email in the evening, and I want to know before I get to class if you've had a problem. A lot of times, one student had a problem, I could solve their problem. If you don't communicate, you can't solve your problems. Also, try to solve your own problems. That's good, too. All right, where are we? Ionic bonding. That's what we're learning about. How do ions form? So, one of the students asked me when you were working on the Explore Learning, how does an electron lose how does it lose an electron? There's energy in the world. There's heat, there's light, and something encounters an electron, and it hits the electron, it gives it a little boost of energy, and it flies off. And that's how you form a positive ion. And a negative ion, that's called a cation. And the negative ions, they form because these stray electrons are attracted to the nuclei because opposites attract. And but we're going to work on these things, and we're going to learn about these ideas in detail through this short presentation. It's only 15 slides. Let's get going. Okay. Let's look at sodium. First, let me read the top. Atoms want to be isoelectronic with noble gases. Let's go over that. Iso means the same. Atoms want to look the same as noble gases. Now, I was all kidding last PowerPoint with the different pop icons that sometimes students like to look like, or adults too. But isoelectronic. So sodium wants to end up looking like neon. Sodium's electron configuration is as shown below. Okay, 1s2, 2s2, 2p6, 3s1. If you did a dot diagram for sodium, it would have one dot. But sodium wants to lose one, and then if it does lose one, it then has 10 electrons. It's lost something negative, so it becomes positive. If you lose something negative, you become positive. If you get rid of a cold, you feel better. I feel positive today. I lost my cold, and that's the nature of the octet rule. So 1s2, 2s2, 2p6. Now there's some extra writing on this slide that I can't quite figure out. 3x plus 4, 9 divided by 3. So if I have a chance, I'll revise it and get rid of that. But it's the electron configurations that we need to focus upon. Chlorine, on the other hand, looks like neon and then 7 extras, 3s2, 3p5. It has 7 dots, 7 electrons, 7 valence electrons. It wants to end up isoelectronic with argon. Feel free to stop the presentation, look at your periodic table, find argon, find chlorine, and see that if chlorine would gain one more electron, it would have the same number of electrons as argon. And so its normal electron configuration is 3s2, 3p5. But then it becomes stable by gaining an electron, by becoming a -1 ion, an anion. Positive ions are cations, negative ions are anions, and then it'll be isoelectronic with argon. All right, so the idea that the elements like to gain or lose to be isoelectronic like a noble gas is a really important idea for you to get down. Well, the rest of the story is pretty easy. Na, having lost one, tends to be +1. Cl, having gained one, is -1. And they're attracted to each other. And really, NaCl, salt, is 2 particles. It is not considered to be 1 particle. It's 2 particles, the result of the attraction between Na and Cl. When we science teachers have a little free time, what we like to do is to discuss what sequence of courses is best. There's a big movement out there that says physics should be first, and that's where you would just kind of talk about the opposites attracting and why and all that. Others, what we do here at Lawrence is biology with first, and I'm sure there are people that argue that chemistry should be first. But so it's hard for me to expect you to fully understand why positive attract negatives. I'm not even sure I do, but they do. So once you form the positive and the negative, they attract each other, and that's a key idea too. Opposites attract, like charges repel. In the previous podcast, in 7-1, we learned about the pattern that 1 for the first column, sodium, 2 for magnesium, 3 for aluminum, 4, 5, 6, 7, 8. But there's also a pattern in the charges that the ions tend to have. It's like a mountain, up and then down. +1, +2, +3, plus or minus 4, -3, -2, -1, and the noble gases tend to have no charge. I'm sorry to say, but I need you to memorize that pattern. Now, when I say sodium likes to be +1, I don't just mean sodium likes to be +1. The other elements in that column, or group or family, lithium, potassium, rubidium, also like to be +1. Hydrogen's a little weird, in that it does become a +1 ion, but it also will become a -1 ion. Hydrogen, if it gains 1 electron, will look like helium, which is a noble gas. Even though it doesn't have 8, we still say that's following the octet rule. And hydrogen sometimes can be fit above fluorine in the periodic table. Once again, when I say things like that, and hydrogen belongs here, it's good for you to pause and look at the periodic table. While I'm creating this podcast, I'm staring at the periodic table, thinking about it, and thinking about what I explained to you. So if you have any questions, be sure to ask. Okay, now we're going to look at the formation of a more complicated substance, aluminum oxide. The naming convention, which is really more about Chapter 9 and Chapter 7, when you name an ionic compound, you write the name of the positive one with no changes, aluminum. And when the ion forms for the oxide, you don't call it oxygen anymore. You change this ending to an IDE ending, aluminum oxide. So we're going to discuss the formation of aluminum oxide. And if you want to read about those rules, you can peek ahead into Chapter 9. Chapter 8 has to do with covalent bonding. So aluminum oxide, aluminum has 3 dots, and oxygen has 6 dots. Okay? So aluminum wants to lose 3, but oxygen wants to gain 2. So when if aluminum loses 2 and oxygen gains 2, oxygen would be stable, satisfied, happy, but the aluminum wouldn't be. It would have an extra electron. The oxygen there needs to be another oxygen. So then another oxygen might be encountered by that aluminum, and then another electron would go over there. Then the top aluminum would be empty of electrons, good, but the oxygen would only have 1 electron on the second oxygen. Well, it all works out when you have 2 aluminums losing 6 electrons and 3 oxygens gaining 6 electrons. I can't emphasize enough how many times I will, on our next test, ask about your understanding of this idea. So this is something that if this format isn't working for you, let me know and we'll work on it. But I want to point out a resource, which is a animation of this, which I have posted on my teacher page for you to see. So try and check out that animation. It's called 7-2 animation, I think. This slide I've used when I've been observed before, and it's very complicated, but it summarized everything. Alright, so it's got a mini periodic table skipping the middle, because the middle, I don't know, it's weird. So first, we have the columns up top, 1, 2, 13, 14, 15, 16, 17, 18. The 18 looks a little weird. You see that? It's 1, 8. Sometimes when I'm teaching, I might not even mention that or even notice that. All right. Then the dot pattern is shown. 1 dot, 2 dots, 3 dots, etc. 4, 5, 6, 7, 8. The one exception to that is helium. And then L and G stands for lose or gain. The column 1 likes to lose 1. Column 2 likes to lose 2. Column 3 likes to lose 3. Column 4 can't make up its mind. Sometimes it gains, sometimes it loses. One of the natural questions that emerges when I point this out to students is that how does it decide whether it's going to lose or gain? And the way carbon decides whether it's going to lose or gain is based on who else it's bonding with. If carbon is bonding with someone to the right of it that can only gain, then it loses. And if carbon is bonding with someone who loses, then it will gain. And if carbon is bonding with itself, then it shares. But that's a story for chapter 8. And then on the bottom row, I show that the charges that these atoms tend to take on, +1, +2. So this is an important slide to understand fully as well. These are important ideas, and that's why I'm glad that they're available to you persistently for you to check it out. Now, this is my animation slide. If you go to our teacher page, you can watch an animation of the aluminum losing its 6 electrons and the oxygen gaining its 6 electrons. I haven't figured out how to get that animation to play for you. I know that there's some screen capture technology that will work, but for now what I'd like you to do is pause, go download the PowerPoint slide, watch it. Hopefully it may or may not work on OpenOffice, so you should be able to use something called a PowerPoint viewer to see the animation properly. Let me know how you're doing with that, and we'll try to work out a solution together if you can't see the animation. And I will probably show this in class as well. Alright, now we're going to form a compound between calcium and oxygen. How many dots does calcium have? Did you say 2? 2 would be the number of dots that calcium has. It wants to lose 2. How many dots does oxygen have? Did you say 6? It has 6. And it wants 8, so it wants to gain 2. So this looks like they're going to be good partners. A way to get the formula is to use the crisscross rule. It's like a cheer. Criss, cross, reduce, rewrite. The positive on the one side becomes the subscript on the other side, and the negative on the one side becomes the subscript on the first side. So if you have Al trying to form a compound, which is +3, with oxygen, which is -2, if you crisscross them, you get Al2O3. Right? We're going to do an activity shortly where we take Al, which is +3, and Cls, which are -1, and we're going to kind of use chips to make this tactile and to help you understand this ionic bonding. So look forward to that activity in class. All right, so this content covered 7.1, 7.2, and 7.3, and it's time for us to go to class and see if we understand these things and see if we can answer questions and apply them to new areas. Things that you weren't understanding, let me know. Please have read 7.1, 7.2, and 7.3. Aluminum bromide, AlBr3. Al is +3 and 3Br is -1. Does this make sense? Now this is going to look weird to you because ammonium is a type of thing called a polyatomic ion. There are polyatomic ions are when particles are charged, and it's a group of atoms. So some of these ideas we'll talk about in class as well.